Hi everyone, and welcome to your second warm-up of the week. What I wanted to do is we've been working with elimination, which is great, but because we are getting towards the end of this section on systems, I just want to kind of circle back and review how to solve a system from substitution, which was one of your warm-ups last week. At the end of the week, you have kind of like a review quiz type assignment, just reviewing all the different methods of solving a system: graphing, substitution, and elimination. The card sort was supposed to be a nice interactive activity, kind of pulling all of those methods together. If you have any questions when you're in it or need any help in the Desmos activity, please let me know. I thought it was something a little bit different, a little bit fun than your normal Delta Math assignment. All right, looking at the first problem in the warm-up, hopefully you notice they're both in slope-intercept form. So because both of my equations are in slope-intercept form, not the standard form we've been seeing with elimination, that needs to kind of be a red flag. Like, oh, I can do substitution here because if they're both in slope-intercept form, I can just set them equal to each other. So that's what I'm going to go ahead and do. Whenever you set them equal to each other, you will always end up with x's on both sides and numbers without x's on both sides. So we're going to have to move things using addition or subtraction. Okay, we can't combine across an equal sign, so we're going to have to add or subtract to both sides. So if I want to get my x's on the same side, I'm going to decide to move the 5x over. All right, if you want to add the 2 over, you can do that first too, either way. So I'm going to subtract 5x. The 5x's cross out. Don't lose this negative sitting in front of the 2 here. So that comes down. Negative 2 is equal to 7x minus 5x is 2x, and then plus 14. So when I move this 5 over, my x ends up on the right side of the equal sign. So I have to make sure that when I move my numbers, I have to subtract the 14. Because if I add the 2, then I overload this side and there's nothing over here. So I want to even it out. So I'm going to move the 14 by subtracting 14 on both sides. Negative 2 minus 14 is a negative 16 equals 2x. So now my variables are on my right. My constant, my number without a variable, is on the left. My last step is I'm going to divide. And I get x is equal to a negative 8. Okay, only half my solution. Remember, it's a point. So I have the x coordinate. Now I have to find the y coordinate. So since both my equations are in y equals, it's really easy. I just have to substitute in and evaluate. It doesn't matter which one I choose. I'm going to choose the top one. Y is equal to 5. I now know that x is negative 8 minus 2. 5 times negative 8 is negative 40. Negative 40 minus 2 is a negative 42. Okay, so that's my y coordinate. Good thing I didn't try to graph this. There's no way that would have fit on my coordinate plane. And my solution is negative 8, negative 42. When I go to look at my second example, I notice neither of my equations are in slope-intercept form. Instead, I have one in standard form and I have one set equal to x. So because they're both not in standard form, I'm not going to use elimination. I have an equation that's x equals, which means I can actually substitute it in for x in my first equation. So here's my x equals. X equals, I'm going to substitute it in for that x there, which means I'm going to pull out the x in my first equation and put the 4y plus 3 in. All right, so this is what it's going to look like. A little bit different. I have the 2. I pull out the x, replace it with what's in my circle, what x equals, which is 4y plus 3. Whenever you substitute in, you always use parentheses. Then let's finish that original first equation. Minus 5y is equal to 12. Okay, because I have parentheses and a number sitting outside, I'm going to distribute first, which means I'm going to multiply the 2 by both terms in those parentheses. 2 and 4y is 8y. 2 and 3 is 6. Minus 5y equals 12. Very different this time. Your y's are on the same side of this equal sign. Unlike over here where they were in opposite sides, so we had to move by addition or subtraction. Here we can combine like terms. They're on the same side. So I'm just going to do 8y minus 5y. If I combine those, I'm left with a 3y plus 6 is equal to 12. Then because my y is on my left, I'm going to move my 6 to the other side, subtract 6. 3y is equal to 12 minus 6 is 6. Divide by 3. And y is equal to 2. So again, half of my answer, and this is actually the second half. So we know that the y coordinate is 2. So now I'm going to substitute back in. It's easiest to go right to this red circle. Okay, I have x equals, well, x is equal to 4. I now know that y is 2 plus 3. 4 times 2 is 8, and 8 plus 3 is 11. So my solution is the point 11, comma 2. Okay, so when you're doing your warm-up, please make sure you have all of this work just like I did here. If it's easier to put it on paper, just take a picture and upload it. Today, if you're doing this the second day, you should be working on, or the second time you're on doing math, you should be working on the word problem videos. Please watch those Edpuzzle videos. I made them. It's me in our classroom doing just examples of word problems, so then you can do your Google form. If you have any trouble while you're doing your Google form, please shoot me a message and we'll go through some problems together. Okay? I hope you have a great day and I'll see you soon.